I hope all of you are doing good. Let's start today's chapter, integers. Introduction. We have already studied about integers in the previous class. In this chapter, we shall recall them and further study about multiplication and division of integers and properties of operation on integers. Numbers on number line. We can represent whole numbers on the number line as shown. See, these are the natural numbers, these are the whole numbers. From the above, we see that on moving towards a right, from the 0 mark on the number line, the value of the number increases, right? And on moving towards the left on the number line, the value of the number decreases. So, the collection of the numbers, that is -4, -3, -2, -1, 0, 1, 2, etc. is called integer. The numbers 1, 2, 3, 4, etc. are called positive numbers or positive integers, and the number -1, -2, -3, -4 are called negative numbers or negative integers, right? Addition of integers. When we add two positive integers, we get an integer with a positive sign, okay? For example, +6 plus 4 is equals to +10. When we add two negative integers, we get an integer with a negative sign. -6 plus -3 is equals to -9, right? So, when we add a positive integer to a negative integer, then we subtract them and put the sign of the greater integer. The greater integer can be decided by ignoring the signs of the integer. For example, +6 plus -9. The answer is 3 because 9 minus 6 is 3, and sign we will put here minus, okay? Now, subtraction of integers. When a larger positive integer is subtracted from a smaller positive integer, the difference is a negative integer, okay? For example, +4 minus +9. So, we get a 5 but -5. So, in order to subtract a negative integer from any given integer, the additive inverse of the negative integer is added to the given integer. For example, -6 minus -9 is what? -6 plus 9, that is +3, right? Thus, the subtraction of an integer is the same as the addition of its additive inverse. Both addition and subtraction of integers can be shown on a number line. Exercise 1.1. We have to verify A, whether A minus B is equals to A plus B. Okay, so first we will take LHS, right? So, A is 25 and B is 30. A is 25 minus 30, okay? So, 25 plus 30 is equals to 55. Now, take RHS A plus B, that is 25 plus 30 is equals to 55. LHS is equals to RHS, hence verified, right? Next, multiplication of integers. The product of two positive integers is a positive integer. Product of two positive. For example, 8 into 5 is plus 40. The product of a positive and a negative integer is a negative integer. Example, 12 into -7 is -84. The product of two negative integer is a positive integer. -15 into -7 is equals to 105. If the number of negative integers in a product is even, then the product is a positive integer. For example, first let's count the number of negative integers. Negative, or you can say negative sign. 1, 2, 3 and 4. Okay, so the even number, that means the product we will get will be the positive. If the number of negative integers in a product is odd, then the product is a negative integer. Okay, first count negative integers 1, 2, 3, 4, 5. Okay, number of negative integer is an odd number, that's why we will get the product in negative only. Okay, next, division of integers. Division is the inverse of multiplication. If we divide a positive integer by a positive integer, we get a positive integer. Example, 12 divided by 4 is equals to +3 because both are positive integer. And if we divide a negative integer by a positive integer, obviously we get a negative integer. For example, -36 is divided by 9, we will get -4. If we divide a positive integer by a negative integer, we get a negative integer. Okay, means +40 divided by -5 is -8. If we divide a negative integer by a negative integer, then in that case we get a positive integer. For example, -36 divided by 9 minus 9 is 4, plus 4. So for any integer a into o, a into 0 is equals to 0 into a is equals to 0. And a divided by 0, we cannot divide any integer by 0, so it is not defined. Okay. And 0 divided by a is equals to 0, where a is not equals to 0. Now, properties of integers. Closure property. Closure property under addition. Integers are closed under addition. For any two integers a and b, a plus b is an integer. Okay. Example, 4 plus 7 is equals to 11, which is also an integer. Closure property under subtraction. Integers are closed under subtraction. For any two integers a and b, a minus b is an integer. For example, minus 12 minus 8 is equals to minus 4, which is also an integer. And closure property under multiplication. Integers are closed under multiplication. For any two integers a and b, a into b is an integer. For example, 8 into 5 is equals to 40, which is also an integer. Okay. Next, closure property under division. Integers are closed under division. For any two integers a and b, a divided by b, okay, may not be any integer. Okay. So, example, minus 4 divided by minus 8 is what? Minus 4 by minus 8 is equals to 1 by 2. It is not an integer, right? Commutative property. Commutative property under addition. Addition is commutative for integers. For any two integers a and b, a plus b is equals to b plus a, right? Example is 8 plus minus 3 is equals to 8 minus 3 is equals to 5, and minus 3 plus 8 is equals to also 5. Okay. Commutative property under subtraction. Subtraction is not commutative for integers. For any two integers a and b, a minus b is not equals to b minus a. For example, 2 minus 1 is not equals to 1 minus 2, because it is 1, it is minus 1. Okay. Commutative property under multiplication. Multiplication is commutative for integers. For any two integers a and b, a into b is equals to b into a. Okay. Example, 8 into minus 7 is minus 56, and minus 7 into 8 is also minus 56. Okay. Commutative property under division. Division is not commutative for integers. For any two integers a and b, a divided by b is not equals to b divided by a, right? Next, associative property. Associative property under addition. Addition is associative for integers. For any three integers a, b and c, okay, a plus b plus c is equals to a plus b plus c. Okay. Example is given here, which also proves the associative property under addition. Okay. Next, associative property under subtraction. Subtraction is not associative for integers. For any three integers a, b and c, a minus b minus c is not equals to a minus b minus c. Okay. Next, associative property under multiplication. Multiplication is associative for integers. For any three integers a, b and c, a into b in bracket into c is equals to a into b into c. Okay. For example, minus 3 into minus 4 in bracket into 5 is 12 into 5, 60, and minus 3 into minus 4 into minus 5 is what? Minus 3 into minus 20, that is 60. Okay. Next, distributive property. Distributive property of multiplication over addition. For any three integers a, b and c, a into b plus c is equals to a into b plus a into c. For example, 5 into 6 plus 2 is equals to minus 40, and 5 into 6 plus minus 5 into 2 is also minus 40. Okay. Next, distributive property of multiplication over addition. For any three integers a, b and c, a into b minus c is equals to a into b minus a into c. For example, the c, 4 minus 4 into 8 minus 3 is minus 4 into 50, that is minus 20, and minus 4 into 8 minus 4 into 3, that is minus 32 minus in bracket minus 12. Minus 32 plus 12 is minus 20. Thus, the distributive property of multiplication over the operations of addition and subtraction is true in the case of integers. Okay. Identity under addition. Integer 0 is the identity under addition. Thus, for any integer a plus 0 is equals to 0 plus a is equals to a. Example, 6 plus 0 is what? 6, and 0 plus 6 is what? 6. Identity under multiplication. The integer 1 is the identity under multiplication. Thus, for any integer a into 1 is equals to 1 into a is equals to a. Okay. Exercise 1.2. Find minus 2 into minus 3 into minus 6 into minus 1. Okay. Multiply, but before multiplying, let's add the number of negative integers. 1, 2, 3, 4. Okay. It's an even number. That means the product will be positive. 2 into 3 is 6. 6 into 6 is 36. And 36 ones are 36. So, plus 36. Right? Things to remember. We can represent whole numbers on the number line. 1, 2, 3, 4 are positive integers. Minus 1, minus 2, minus 3, minus 4 are negative integers. Division is the inverse of multiplication. 5. Integers are closed under addition, subtraction and multiplication. Therefore, for any two integers a and b, a plus b, a minus b and a into b are again integers. 6. Integers are not closed under division. 7. Addition and multiplication are commutative for integers. For any two integers a and b, a plus b is equals to b plus a and a into b is equals to b into a. 8. Subtraction and division are not commutative for integers. 9. Addition and multiplication are associative for integers. For any three integers a, b and c, a plus b plus c is equals to a plus b plus c, or a plus b into c is equals to a into b plus c. 10. Subtraction and division are not associative for integers. 11. Distributive property of multiplication over the operations of addition and subtraction is true in the case of integers. For any three integers a, b and c, a into b plus c is equals to a into b plus a into c. A into b minus c is equals to a into b minus a into c. 12. Integer 0 is the identity under addition. Okay, for any integer a plus 0 is equals to 0 plus a is equals to a. And number 13, integer 1 is the identity under multiplication. For any integer a into 1 is equals to 1 into a is equals to a. Okay students, now you will do practice of the remaining questions.